Hello, my name is Almudena López de Rego, and the project I'm going to present addresses the matter of indoor environment quality in education centers through the comprehensive evaluation of some comfort and health parameters as the impact of a very simple renovation in a classroom in order to demonstrate whether it was successful or not. Indoor environment quality attracts scientific interest, especially when it concerns the health of vulnerable populations such as children. The main aspects that define the quality of an indoor environment are hygrothermal comfort, acoustic comfort, luminous comfort, and physical, chemical, and microbiological pollutants in the air. Studies carried out conclude that heat can affect concentration, good lighting results in better job performance, and air quality influences learning. Unfortunately, many schools do not provide adequate indoor conditions and need to renovate in order to provide an appropriate learning environment for the children. And that is the case of the space that we chose to work with in this project. The Waldorf Aravaca School is located in a residential area very close to the city of Madrid, and it educates children between 5 and 11 years old. Classrooms under the roof have very poor daylight levels and ineffective ventilation. The objective is to prove that the small envelope renovations can highly improve comfort and health parameters in schools, and that very good performance levels can be achieved in those fields without compromising the hydrothermal comfort during school hours in Spain. This photograph shows the original state of the classroom, and here you can see the new learning environment created just by adding 4 big roof windows with some control devices. The methodology we used consists of the integration of the 3 next approaches: theoretical studies, experimental studies, and participative research. They respectively include energy and daylight simulations, comfort parameters monitoring, and user's perspective. Temperature, humidity, and CO2 sensors have registered data. Daylight measurements have been taken before and after the renovation. The collection of the data was taken for 5 months before the intervention, and for 8 months after the renovation that took place during the summer break of 2019. The project was supposed to run until the end of the school year, but the COVID situation unfortunately didn't allow us to get any later measurements. Also, the interviews to the users had to be postponed to the upcoming school year. However, the results that we were able to get by now are very satisfactory. When looking at daylight levels and visual connection to the surroundings, the improvement of the classroom is easily visible. Daylight simulations were carried out to determine the right amount and size of the windows. The calculations show that with only 2 windows facing north, daylight levels are acceptable, suggesting that in case of extreme overheating, the roller shutters of the windows facing south could be closed and still achieve a median daylight factor of 0.6% across the whole room, which is equivalent to 300 lux. On the other hand, according to the energy simulations performed with Design Builder, artificial lighting consumption drops to 10% of its original value, showing then a great improvement. Measurements of daylight have been taken on all 27 students' tables. The median amount of daylight inside is at least 10 times higher after the renovation on all weather and seasonal scenarios. According to them, daylight autonomy is ensured through the most part of the school hours. And of course, glare is addressed with the inside blinds and exterior shutters. The concentration of CO2 shows big changes. CO2 concentration before the renovation was over 4,000 ppm for more than 75% of the school hours, reaching values up to 8,400 ppm, so really far from the 1,000 ppm line that you can see in green. Then the classroom had really serious indoor air quality issues. The improvement of this parameter is outstanding, even when the smart ventilation was off and air renovation depended on users. In January 2020, 85% of the measurements are under 1,500 ppm, and the curve is much more stable. As for thermal comfort evaluation, summer and winter scenes have been compared to determine if the addition of glazed surface on the envelope has had a negative impact on indoor temperatures. Results show that thermal comfort has not been penalized by the new windows in any of the months during which data was collected. In winter, even with the necessary level of ventilation to ensure an adequate indoor air quality, indoor temperatures are a little closer to comfort ranges than before the renovation. Of course, in order to extract conclusions on the performance during the cooling season, we will need further measurements during June, usually the warmest month of the school year, as it was planned. At this moment, we can compare the data of May and September. Temperatures gathered after the renovation show almost no points over 26 Celsius degrees, thanks to the possibility to ventilate properly as well as to shade the windows when necessary. Indoor temperatures are very similar in both scenes in summer, even though the envelope has increased the glazing area in more than 3 square meters. Considering the outstanding improvements in daylight, we find this information very positive. To finalize, we conclude that all the considered parameters show notable improvements or positive results. As next steps, we have a few pending tasks. Interviews and workshops with students and teachers will be rescheduled to at least autumn of 2020. Monitoring results for June are necessary to ratify that cooling season is also safe from losing thermal comfort with generous amount of new glazing. And this data will not be collected until June 2021 due to the COVID-19 situation. And as the next phase, we'd like to be able to analyze the impact of automated natural ventilation with smart windows, which were actually installed this time but couldn't get programmed in time for the monitoring. We consider the project successful to support that small envelope renovations can highly improve comfort and health parameters in school. Thank you for your attention.